Okay, so here we have, I think this is 2004, question 6 on the physics paper. And the first part is to define force and momentum. You should all have your definitions learned off. So I'm not actually going to do these first few parts. I've got that one done as well on, it's included with the 2009 question. You could use just quickly that we're going to be using force equal to mass times acceleration, and momentum is equal to mass times velocity. When you see these, it's a good hint as to what will be asked in the maths part of the question, which is what we move on to now. So I'll just leave them there for the moment. Notice that that's, for that it'll be 27 marks, so you're over half the marks going for those two first sections. What we've got here is a question now on a pendulum bob of mass 10 grams was raised to a height 20 centimeters and allowed to swing so that it collided with a block of mass 8 grams at rest on a bench as shown here. The bob stopped on impact and the block subsequently moved along the bench. So we need to work out the velocity of the bob just before the collision and the velocity of the block after the collision. So there's going to be two things we're going to be using here. So first off, you want to be thinking about energy. The block up here is going to have complete potential energy. Potential energy is given by mgh. When it gets to here, it'll have complete kinetic energy, which is a half mv squared. So we'll do that for the first part. That's all we need to know for the first part. So I'll just highlight that. We're working the velocity of the bob just before the collision, which should be given by this bit here, and we should know all the other factors. In fact, I could probably do this a little bit even mathsy. So the potential energy at the top is going to be equal to the kinetic energy at the bottom. Potential energy is mgh is going to be equal to the kinetic energy, a half mv squared. We'll put in our numbers. Notice that you can actually cancel here, so I might as well just do that, make it that little bit easier. I can cancel this m here and this m here. Fill in gravity, it's 9.8, we're told to give that, so we've got 9.8. We're told the height it's raised to was 20 centimeters. Make sure you use your standard units, so 20 centimeters is 20 times 10 to the minus 2 of a meter, 0.2 of a meter, probably easier to say it that way, is equal to half v squared. So we've got 9.8 times 0.2 is equal to half v squared. Multiply both sides by 2 will be that, is equal to v squared. Our v is equal to the square root of 9.8 by 0.2 by 2. So I'll just do that in the calculator quickly enough if I can. And the calculator's there. So we've got 9.8 times 0.2, input times 2 times 0.2 is equal to that, and we want the square root of it, which is, and which one is the power of 0.5, same thing as the power of a half is the same thing. Okay, and we get a velocity of 1.979. I'm just going to round that up to a velocity of 2 meters per second. So here we have a velocity, this works out to be v is equal to 2 meters per second. So we've got the first part done. That was an easy enough question. The next part then is the velocity of the block immediately after the collision. Now in order to work this, you have to remember that in any collision, the conservation of momentum. Momentum is always conserved. So m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So in this I'll call the block m1 and that m1 and this m2. So we know the mass of the first one. Now again, be careful of your units. So 10 grams is the same as, I'll just go 8. 10 grams is the same as 0.01 of a kilogram. Divide by 1,000, and then 8 grams is 0.008 of a kilogram. Important to use them. standard units wherever you can. Okay, so m1v1 is 0.01 u1, which is the velocity we just have to work out, times 2 plus m2 times u2, that's going to be 0 because it's not moving at the start, is equal to, the first object is not moving, so that's going to be m1 times 0, so it's going to be 0, plus m2 v2. m2 in this case is 0.008 times v2, which is what we're looking for. So multiplying this out, you get 0.02 is equal to 0.008 v2, or v2 is just equal to 0.02 divided by 0.008, which is equal to, divided by 0.008, which is 2.5 meters per second. And there, that's the question. That's it done.